Hello, my name is Carlos Lang, and I will be sharing some details about how the mRNA vaccines work against COVID. These vaccines contain the molecule messenger RNA, which provides your cells with the instructions needed to make the infamous COVID spike proteins. These spikes serve as a sort of wanted poster that your immune cells can recognize, teaching your immune system what to look for in case of an actual COVID infection. Now let's explore in more detail how exactly it is that the mRNA enters the cells. mRNA by itself, without any modifications, degrades incredibly fast. It can be characterized as immunogenic, meaning that it can act as a pathogen-associated molecular pattern for your immune cells' pattern recognition receptors. In addition, mRNA is not able to easily penetrate the cell membrane, thus injecting naked mRNA into your body would be rather inefficient. For these reasons, the mRNA in these vaccines is extensively modified. Modification of its nucleotides prevents immediate degradation by your innate immune system and prevents undesired immune responses. Specifically, the mRNA is modified by using N1-methyl pseudouridine in place of uridine. This modification alone leads to a tenfold increase in translation and prevented the mRNA from inducing an early immune response from toll-like receptors found on macrophages and dendritic cells. To facilitate the entry of mRNA into the cells, the mRNA is encapsulated in lipid nanoparticles. Lipid nanoparticles, or LNPs, are made up of a combination of ionizable lipids, cholesterol, phospholipids, and polyethylene glycols that self-assemble to encapsulate the mRNA. LNPs containing mRNA can be easily internalized and the mRNA quickly translated by antigen-presenting cells at the site of infection and in the lymph node to promote the initiation of an adaptive response. LNPs also protect the mRNA from degradation by nucleases. Now, how exactly does your body respond to the vaccine? Intramuscularly administered vaccines can transfect both muscle cells and tissue-resident antigen-presenting cells near the injection site. The vaccine can also flow into proximal lymph nodes and transfect lymph node-resident cells to activate T and B cells. The mRNA then enters your immune cells via endocytosis-mediated internalization. Once inside the cell, the mRNA escapes into the cytosol where it can be translated into the spike proteins. The spike protein is then degraded to undergo MHC class I presentation or MHC class II presentation to present the antigen to cytotoxic or helper T cells respectively. The antigen protein can also be expressed extracellularly to be taken up once again by an antigen presenting cell. The extracellular antigen can be recognized by B cell receptors on B cells, leading to B cell activation. B cell activation leads to the production of plasma cells, which secrete low affinity antibodies or enter germinal centers where they undergo somatic hypermutation and affinity maturation. The B cell population with high B cell receptor affinity then exit the germinal centers as long-lived plasma cells or memory B cells, which are key in establishing immunity. Exposure to the COVID antigens would reactivate memory B cells for antibody production, allowing for a fast immune response. The long-lived plasma cells reside in the bone marrow to provide immunity for years and up to decades. Thank you very much for your time.